This video is the continuation of the previous video. Now we know what the leading coefficient test is. I have four functions or equations. We are trying to use the leading coefficient test to determine the left hand and right hand behavior of each function. Now, in the previous video, I said instead of memorizing a long sentence, memorizing these 16 letters. So let me show you what these 16 letters mean. Now, starting for the first one, we have y equals to 3 plus 2x to the fifth minus 2x to the third. Now, tell me, where is the highest degree? The highest degree is 5, right? So 5. This is the biggest degree, so therefore the leading degree is 5. What is the leading coefficient? The leading coefficient, you know what? The 5, I will just put it right here. The leading coefficient is the number in front of the x to the fifth, which is equals to 2. Now, the leading degree is this odd or even? 5 is odd, right? So 5 is odd. And then the leading coefficient is positive. Then which one should I choose? Positive. I said Pn. I will just use positive, which is P. So take a look at these 16 letters. Leading degree is odd. Leading coefficient is positive. Then falls to the left and rises to the right. So this is a falls to the left and rises to the right. It is just that easy. And then the next one you might have to look deeper to determine the leading degree. What is the leading degree? Don't tell me it's 1. You have to multiply these three factors. I'm not asking you to, spend 2 minutes to multiply them. So what is the highest degree? When you take this x times this x times this x, that gives you the highest degree, right? Which is equals to 3, right? So the highest degree is equals to 3. How about the leading coefficient? This times that. So you have 1 times negative 5, 5 times negative 1. So the leading coefficient is negative 5. Okay, so this is a 3. The leading coefficient is negative 5. All right, now the leading degree is odd, and then the leading coefficient is negative. That is here, right? Leading degree is odd, leading coefficient is negative. So rise to the left and falls to the right. So this is the rises to the left and falls to the right. All right, so how about number 3? Number 3, what is the highest degree? Number 3, so the highest degree is, don't tell me it's 4. It is not 4. This looks like 4, right? But you have a square over here. So when you square that, do we agree that we will have a negative 1/2 x to the 4th times itself? So x to the 4th times x to the 4th. You add the exponent. 4 plus 4 is equals to 8. So this is a 4 plus 4, which is equals to 8. And how about the leading coefficient? The leading coefficient, you will have to square this. So that becomes a positive 1/2. I mean 1/4. A positive 1/4. So now the leading degree is even. And then the leading coefficient is positive. So we have EPRR, rises to the left and rises to the right. So this is rises to the left and rises to the right. Last one. What is the leading degree? The leading degree is not 1, right? So this is 1, but you have to square that. This is 1, but you have a 6th power. So the leading degree is actually a 2nd power times a 6th power. X to the 2nd multiply x to the 6th. So x to the 2nd power multiply x to the 6th power, which is x to the 6 plus 2, which is equals to 8, right? So the leading degree is even. And then how about the leading coefficient? This is a 1. 1 raised to the 1st power. This is a 4 raised to the 6th power. So what is that equal to? Which is you have a 1 to the 2nd power multiply 4 to the 6th power. I don't really care what that equals to. I care about whether that is positive or negative. This one, please don't forget that there is a minus. So you have the minus the whole thing, which is negative. So you have even negative, which is falls to the left and falls to the right. And then I know you see that there are some graph in here. I'm trying to use this to verify my answer. Let's take a look at the first graph. So the first graph corresponds to the first function. So this is the first graph. What do we have? We have falls to the left and rises to the right. So falls to the left, rise to the right. That is correct. And then the next graph, this corresponds to number 2. So number 2, we have rise to the left and falls to the right. That is correct as well. And then the last one we have this. So this is rises to the left and rises to the right. Let me check the last one, because the last one I'm not sure if this is a mistake. This should be like falls to the left and falls to the right, because the reason I put this graph up is I changed the function in the last minute. This problem, I changed the function in the last minute, so I don't think this is correct. So this one I'm going to erase this. I don't think this is correct. So why don't you use a decimal, graph this to make sure that it falls to the left and falls to the right, because I changed the problem in the last minute right before I make this video. I'm sure that graph is no longer correct. Before I change the function, that is the correct graph. Alright, so that is the end of this video. If you like the way I explain leading coefficient test, give me a thumbs up. Before we go, turning point. We still have turning points. Okay, the first function, number 1, what is the highest degree? The highest degree is equals to 5, so we have at most 5 minus 1, which is equals to 4, right? And then number 2, what is the highest degree? The highest degree is 3, so this is at most 3 minus 1. And then number 3, we have the highest degree is 8, right? N equals to 8, which is 8 minus 1 equals to 7. Is this the first one correct? At most 4 turning point. Yup, we have 2. We have one right here and then one right here. And then the next one, at most 2, we have one right here and then one right there. And then the last one, and then this one, the third one, we have one right here, and then one right there. To this graph, I did this on decimal, so all you have to do is just click on that point. They will show you what the graph looks like. And then the last one, number 4, since the highest degree is equals to 8, and then you have 8 minus 1, which is equals to 7 as well. So the last graph has at most 7 turning points. I am not saying it's exactly 7. I'm saying at most 7. At most 7 means the maximum is 7. It can be 7, 6, 5, 4, 3, 2, 1, 0. Alright, so now this is the end of this video. I will meet you all in the next lesson. Signing out.